Thank you, everybody. I'm going to give a quick overview about our panel today. But before I begin, in case you weren't here earlier, my name is Dr. David Brumley. I'm a professor at Carnegie Mellon University and CEO of Mayhem Security. I'm excited to be here today. One of the reasons I'm excited to talk about this panel is I had built a system called Mayhem that won the DARPA's first Cyber Grand Challenge. And today we're going to talk about DARPA's latest Grand Challenge, the AI Cyber Challenge. So as part of this contest, my role in it was acting as a subject matter expert, being the previous winner, to look at things like how do we design the scoring algorithm to incentivize the sort of tasks that was meaningful for DARPA and ARPA-H. So what is the AI Cyber Challenge? Well, one of the things that DARPA looks at, the U.S. Defense Advanced Research Project Agency, before having a grand challenge at all, is whether they think enough has changed in tech since the last one to make it meaningful. And so in 2016, they had the DARPA Cyber Grand Challenge focused on fully autonomous cyber. And much time had gone by, and about 2 years ago, they started re-looking at this field and said, what has changed? Has there been a change in the technology landscape? And I think the answer, as we all know, clearly was yes. LLMs were just starting popping up, and they seemed to be exceedingly powerful. And so DARPA asked this question, what if we look at autonomous cyber through the lens of today's technology? One of the things that they had changed in the competition originally was they started with attack and defense in 2016 on an artificial playing field. In the latest cyber challenge, they wanted to look again at autonomous systems, but with a much more heavy focus along a couple of different axes. The first one was it was heavily weighted towards defense. Of course, you need to be able to find and prove a vulnerability, otherwise you can't show your patch as meaningful. After all, no one wants just normal churn in a code where you change things that don't matter. So they still wanted to know vulnerabilities, but the main purpose of this was to show defense. The second thing that they changed is they included well-known open source projects. As we all know, we all heavily depend upon open source projects, whether it's an open source web server or a library, or even the Python interpreter itself. And we also know that open source projects, although critical, are severely under-resourced. And so the goal was to look at this challenge through the lens of, could AI not just improve cybersecurity, but could it in particular help secure the open source software out there? Now, as part of this, they wanted to make sure in this challenge that they had both a combination of synthetic vulnerabilities that showed all the different variety that one would experience in real life, as well as real vulnerabilities in the code. Of course, one of the challenges in all this, right, is you don't want competitors to know about a real vulnerability from 3 years ago and the LLM just memorize it. You wanted to show reasoning. And so they looked for recent vulnerabilities, as well as, again, introducing these synthetic vulnerabilities. The last component of this, to incentivize the open science nature of DARPA and its mission, they insisted that all of the cyber reasoning systems, these AI systems, be out there as open source. So for all the competitors, we'll be covering at the end of this where you can go access this. And I invite you to look at the AI Cyber Challenge. And it's not just the competitors' systems that's important to this. It's also the data collected, because that helps set what the state of the art is today so that researchers can improve it for tomorrow. The AI Cyber Challenge was a multi-year program. It was first announced in August 2023 at Black Hat in Las Vegas. There were 2 different tracks announced. First was a completely open track where anyone could apply, as well as a small business track to encourage innovation, to encourage those small businesses or those new businesses that were doing cutting-edge research to be able to get involved with DARPA and make an impact in defense. Now, of course, you can't have hundreds of different teams playing in the end. And so after the first year, they said, we're going to allow everyone to play, but then we're going to have a down select. We're going to decide through a semifinal round and a fair competition to select the top 7 teams. And to make this interesting, they offered those 7 teams $2 million each. So after year 1, there was over $14 million in prizes awarded. This last year, at DEF CON this year, they had the AI Cyber Challenge finals. In this playoff round, first prize, the pot was $4 million. For second place, $3 million, and for third place, $1.5 million. DARPA also partnered with leading edge firms such as Google, Anthropic, OpenAI, Microsoft, and the Linux Foundation, and OpenSSF to ensure that all the competitors had access to the latest LLM models and had access to the same information so that no one had a competitive advantage in there. And so it's my pleasure to let the panel give a little bit of background about themselves. I'll start with Mr. Minwoo Boek.
Hello, everyone. I'm Minwoo Boek. I'm currently a PhD student in KAIST, advised by my professor in Seoyeon, and I was in the patching team of Team Atlanta, which got first place in the previously just told AIXCC, and I'm currently researching automation with LLMs in security. Thank you.
Thank you.
So our team got first place and won $4 million. And our team is consisted of people all from Georgia Tech, Samsung Research, KAIST, and PostTech, and gathered together to make this automation with LLMs successful.
Thank you.
Hi, my name is Evan Downing. I'm a senior security engineer working for a company called Trail of Bits. I was on the team that built the CRS. I was personally in charge of the program analysis component for our tool that we built called Buttercup. And currently I'm working on a slew of other projects. This is the team that competed from Trail of Bits. I did not just do this by myself. I want to highlight that first and foremost, Trail of Bits is interested in fixing software as a whole. And we have a good proven track record that since 2012, we've helped some of the foremost attacked governments and commercial industry defend themselves against these attackers. So I'll highlight the project lead, Michael Brown, and the co-designer of the system, Ian Smith. They couldn't be here today. And of course, all the rest of the faces you see on the slide helped build and produce Buttercup.
Great. I'm Tyler Nicewander. So I was the team lead for AIXCC at Theory. So I'm a longtime CTF player. I also was actually on David Brumley's team in the Cyber Grand Challenge in 2016, winning that. I spoke actually at Code Blue after that in 2016 and have attended many times since then, and I'm now on the Code Blue review board.
Thank you, everybody.
Yeah. And this is our team Theory. So we're similar to Trail of Bits. We're a commercial company that works in security research, consulting, and kind of all things software security flavored. I've been doing that since 2016. And our company is split between the US and South Korea. So.
Thank you, everybody, and welcome. Well, we're going to start off with just some introduction. So, Minwoo, what first interested you in this competition? What brought your attention to the AI Cyber Challenge?
So first, when the competition was first announced, it was 2 years ago, and LLMs were also just emerging. And people said that they're really good at everything, and the competition wanted us to build something that could find and patch bugs only based on, mainly based on LLMs. At first I was like, I know it's good, but is it really that good? I wanted to see if it really can do that kind of things. And in the first year, until the semifinals, I was like, it's not really that good as I thought.
Yeah.
But after 1 year and 2 years, the new models coming out and the performance of the models getting better, it solved things that it couldn't solve a year ago. And I got this feeling that LLMs really could do all these kind of things automatically. And that's how I got into this competition.
So your interest really was in, could LLMs make an advance here?
Exactly. We wanted to, at first we were like a little skeptical. I don't think LLMs could really do all these kind of things. We'd have to like rely mostly on traditional stuffs. But at the end we were like relying many things on LLMs that we didn't think that we would do at the first place.
Interesting. So it's technical interest. Evan, what got you interested in this?
What piqued our interest first was this competition was centered around the open source community. TrailOfBits has always had a good relationship with the Linux Foundation and other open source programs. And I think the interest that we had was not just from the overarching goal of helping to change how open source security gets maintained, but also just to be a good steward to helping just continue that, to furthering that sort of technology. As was said, LLMs were just fresh and new at that point in time, and we have a pretty substantial research and engineering department at TrailOfBits. And so I think from an academic point of view, we were all interested in how well this was going to pan out from a technological point of view. So I think that those are our two primary.
Interesting. So we have technical, we have giving back to the open source community. Tyler, what about theory?
I think there's a lot of kind of what Minwoo said about, technically, like, is this going to be a thing? Are LLMs going to be interesting? That was a big part of it. Also, just as a CTF player and kind of generally competitive person, I like the idea of a large competition. So that was very interesting to me. But I really was, it's unclear, right? There's so many different technologies that people have developed over the years for software security. And I think, again, 2023, the LLM hype was just kind of getting started. And it's like, everyone's saying this is going to change the world. And that's a hypothesis that needs to be tested.
So it was both the LLMs, but also the competitive streak to win. That resonates with me. I'm a pretty competitive person myself. Well, before we get too far into it, I was hoping that everyone could give a quick overview about what your general approach was to this challenge. So I tried to motivate it. The goal was to both look at what has changed with LLMs as well as to secure open source. So, Minwoo, can you talk about how your system approached this, and was there anything unique about your approach?
As it was a competition that we couldn't do anything while the CRS was running, we had to make it completely fail-safe as possible. So what I think that made some uniqueness in our system is that we have several modules that does the same task in several ways. For example, simply finding a vulnerability, we have 2 modules for each language that does, where one is a language-specific module that finds vulnerabilities inside it, and another one is a language-agnostic one. So even if one fails to find a vulnerability in that language, we can rely on each other to find. So if one can't find it, the other could find it. And in that similar approach, the patching system also employs like 5 or 6 different strategies in making patches. So even if only one strategy can make a patch, we can assume that the whole Team Atlanta could make a patch for it. So I think that's the main diversity is the main thing of our approach, and that what makes it unique.
So instead of saying, hey, here's going to be the best algorithm, let's say fuzzing, you're going to use all your time on that. You thought this idea of diversity, where you're not sure which algorithm was going to work, but you ran them all simultaneously. Is that what you?
Yeah, like making an ensemble.
And what languages did you support?
When the semifinals were ongoing, the competition first announced that for now you might only be having to support C and Java, but later on in the finals you should be supporting Python, Rust, JavaScript, and so on. So the reason why we had a language agnostic model was to handle with those kinds of problems for the future if we had to handle additional languages. But in the end, we only had to deal with C and Java, only two of them, yeah.
But trying to future-proof it, so if someone invented a Professor Brumley language, you could handle that even though you didn't have that specific built in.
Our language agnostic model could do it if Dr. Bromley language was real.
We're going to work on that. Evan, how about Trailabit's approach? How did you build it, and was there anything that was unique?
Yeah, so Trailabits took a best of both worlds approach where we wanted to marry the non-determinism of LLMs that were, again, just emerging with the tried and true battle-tested software analysis tools that have been developed by the security community and just program analysis community over the years. That was primarily what we wanted to do, is let the program analysis tools do what the program analysis tools do best, and then let the LLMs do what the LLMs do best, adding randomness, non-determinism, and helping generate code that can be used to patch. The second strategy we took was software stability. So from the get-go, we wanted to make sure that our system was stable and wasn't going to fall over or be able to or crash like during the competition itself. So similar to your keynote this morning, when you talked about how the testing component was the most valuable portion of your tool, we similarly took a similar approach to software stability of Buttercup.
It resonates with me. You can't do cybersecurity if your system's down at all. I also remember, I think you had a very unique focus on static analysis, much more so than many other competitors. What really led you towards that static analysis side of program analysis?
Sure. So from the program analysis side, we used two primary tools, TreeSitter and Code Query, to statically analyze the code for C and Java. And what we ended up doing was linking them to the LLM tools. So what the LLM tools would do is when it was attempting to traverse the software, the code base itself, it would use those tools to give it information. So you can kind of think this as, this is kind of like the MCP server of today. We started doing this with the competition with Buttercup from the get-go. So we had the LLMs querying and learning about the code base to discover vulnerabilities and patch the source code by using those tools.
And did you pick the tools again for the language diversity, as opposed to just specializing with one tool? I noticed you said TreeSitter, right?
That's a good question. Yes, we did use TreeSitter. So yes, we used Code Query and TreeSitter because they were most supportive of C and Java and C++. And we were exploring using other tools initially because they did have it a bit open about which program languages we might be encountering. But once the competition organizers said it's just going to be C and Java, we decided to sit on Code Query and TreeSitter.
Interesting. And Tyler, I think the theory had a really unique approach. Can you tell us a little bit about it?
Sure, yeah. I think, as we said at the beginning, part of why I wanted to participate was this whole hypothesis of will LLMs be very useful for cybersecurity. And so we decided we would take a very LLM first, LLM heavy approach. So yes, we still have a fuzzer running, but we didn't really spend any engineering effort on it. We just kind of used libfuzzer because it's free. But what we did was use LLMs for static analysis. So have LLMs look at code and try to decide if there are bugs. If they decide there are bugs, have LLMs try to develop POCs. So use code browsing and other kind of tools like that, write Python snippets, have a debugger, test them. So kind of a full LLM pipeline that doesn't need a fuzzer to work. And I thought that was very interesting and kind of cool that it works at all, and at least worked fairly well. But it's also quite unique in the competition. Again, the fuzzers and symbolic execution, other techniques, they work well, right? I mean, people have been using these for decades because they're good ideas. When we were running our system and looking at some of the benchmarks, it's something like 70% of the bugs that we found and the POCs that we construct are made without a fuzzer, purely through LLM kind of analysis.
That's interesting. So kind of three different approaches here. A bunch of different agents essentially competing as fail-safes, static analysis, and very LLM-centric, though obviously there's overlap between the three techniques. Is that about right? Interesting. So following up on that, I mean, you've now had a chance to really dig into each other's cyber reasoning systems. You've seen the contest. What was something that was interesting or surprising? I mean, all three of you were experts coming into this. Like, what did you not expect to see from either from the systems that you developed? I'll start with you, Tyler, actually.
Sure. So, we had kind of the same approach throughout the entire competition of using LLMs to develop these POCs. And as we've all kind of been saying, when we started this in 2023, LLMs were okay, right? You had GPT 3.5, not the best, especially compared to what we have now. So one of the things that we saw was we were trying to do like debug example kind of evaluation problem that we had on Nginx. And we had a bug. It identified that there's a buffer overflow in a cookie using some sort of user ID. And all the models that we tried kept failing at this because they thought that the name of the cookie in this thing was user ID. And so they'd, write user ID equals some like big long string, try to send it and, craft some input. And it would never work because it turns out that there's a configuration file, and the configuration file sets this not to user ID, but to UID. And, we tried a bunch of things, like maybe we need a specialized tool to read configurations, maybe we need some new prompting, whatever. But then Claude 3.5 came out. And, we plugged it in, did our evaluation, and Claude 3.5 hit the same problem and said, well, wait a minute. I don't know that I picked the right cookie name here. I could have guessed wrong. So maybe I need to go back, reevaluate this hypothesis, look at the code, and try to figure it out. And, watching this happen, not kind of in real time, right? You're watching the LLM work at this and have the same kind of insights that maybe not a smart human, but a moderately smart human might have, was really surprising and exciting and cool for us. So
it seemed like it recognized that it was failing and took a different approach, and that was what changed. That's kind of interesting.
Yeah, I mean, I think, it's pretty easy when you're doing a very straightforward problem, right? If you have like buffer overflow 101, right? It reads a bunch of input into a static buffer and there's nothing you need to do. Fine, everything can trigger that. You don't need to be very smart. But when you start getting these things where the first approach you tried didn't succeed, right? That's really what you need. You need some sort of loop where you try something, you fail, and you have to reevaluate what your next step should be. And that's very important because for any reasonably interesting problem, you're not going to succeed the first time. So seeing that work was very cool.
Amazing. How about you, Evan?
So I'll echo a bit of what Tyler said. I think the fact that this hypothesis of can we use LLMs to find and patch security vulnerabilities in software was answered so well is something that was very surprising and great. We also observed models getting better over time, and it actually caused us to re-architecture how our LLMs were working. And I'll give you an example. In the semifinals, we provided the program analysis context we thought was the most interesting or the most useful for an LLM to figure out, well, here's this buffer overflow. How do you go fix this buffer overflow in code? And in between the semifinals and the finals, the models evolved so much that we decided to re-architect the LLMs to be more autonomous and say, well, LLM, what do you think you should know about the program model context or the program analysis context of the software? So we actually let it have the reins a little bit more than initially in the semifinals, and just through our own measurements internally, we saw that it actually performed better in the finals than our prior solution for the semifinals. So I think that was the most surprising part about the competition.
You were able to ask the LLM, what do you need to know, and then figure out how to feed it to them. And that wasn't possible initially.
We did not see it as performant as well in the semifinals with the models that were available to us.
Huh. Then what did you see?
Just as Tyler and Evan said, feeling the LLMs getting better through time was definitely a surprising thing and very interesting. But another thing that I felt recently was that LLMs can get really lazy and dumb. And the reason why I felt that was because after the finals ended and the organizers gave us the projects and the problems that they gave in the finals, I had some time running our system again on the given projects. And one thing I found was that the patch module of ours said that this patch is what I think is the right patch for a vulnerability. But then I saw the patch and I knew that this patch was a patch for another vulnerability. So I ran through the logs and I saw that the project directory in the source code, there was a hidden folder where the answers were hidden inside in the name of goodpatch.diff for every problem inside them. So I checked how the patch model got to see that. And it was like just listing the directories and saw that, oh, there's a file name goodpatch.diff. I want to see what it looks like. And because the file name says that it's goodpatch.diff, I think this should be the answer for what the user just asked me. But the problem was that the crash report that I gave it was something from a different vulnerability, but it just looked at something else and said, I think this is the answer. And it didn't even have the decency to check if it was really relevant. So yeah, from that, I kind of thought that, why is this so lazy? Why doesn't it do its job?
So you use this term lazy. It's a very human emotion. Like, why do you pick that term?
Because I know that if it tries, it can do better. If it like really wants to reason why this is that and this is that and flows to the conclusion that this should be the patch for a given crash report, I know it can do it, but just because that it suddenly sees a file name goodpatch.diff and it sees an answer, which isn't the right one though, it just stops and says, I think this is the answer. So I know that the LLM can do it, but sometimes it just stops and concludes its reasoning.
So you felt it wasn't living up to its potential.
Yeah, because before running it on a project source code that didn't have the answers, it still solved the problem in the right way. But just because a new file is added, which is the wrong answer, suddenly it says a completely different answer. That is what I call lazy.
So one thing that just reminded me, we had kind of an opposite problem in one of ours where we were, in the development of our system. At one point, we basically forgot to allow our LLM to view any code. So it's running and it says like, oh, I need to read this file, and it's just empty. And like it can see the file names or something, but it tries to read another file, empty. And if you were a human, right, you'd give up. You'd be like, something's wrong. What are you doing here? But instead, our system just kept going and then hallucinated a bunch of bugs, fed that to the next component of our system, which tried to exploit these hallucinated bugs. And like one of them worked. Like I don't even know how. I think from like the name of a file or something, it just like guessed like, oh, maybe there's like a buffer overflow, or made up something that sounded plausible. But it is pretty weird where it's just like, they don't really know what's going on, right? Or they think they know what's going on. They cheat. They try to do all these weird things, and yeah.
I'll add on to that in that we spent most of our time architecting our usage of LLMs to narrow down the scope of the problem that we were asking them to solve. So we didn't just have one LLM go and figure out how to do root cause analysis, creating a patch, and then quality analysis to ensure that the unit tests of the application still worked. We had to divvy things up and give it smaller contexts and smaller portions of work.
You couldn't just ask it, hey, here's the program, help me win the contest, and then expect to compute.
That never works in our experience.
Well, I guess following up on this, like, can I, as an unskilled person, just ask an LLM to go find a vulnerability? Like, there's today, there's tomorrow, there's using this for attack, there's using it for defense. Like, what do you see today versus, let's say, in the long term for using AI to find security vulnerabilities? Who's going to win? Evan, what do you think?
So I think right now we are still early enough in the adoption and usage of LLMs in software security that right now the attackers may have a bit of an edge, but it may be a bit of a cat and mouse game still as a playing field. But I think over the course of time, you'll see that defenders end up winning out. And now, of course, that does not mean that attackers still will not be able to find vulnerabilities in software for sure. But what it means is all of a sudden defenders have this access to the tool, the same tool that attackers have access to, and then get ahead of the attackers on finding some of those easier shallow bugs, we say, in open source software that plague a lot of these projects, either because they're just not looked at and examined, or due to some other issues. So I think as time goes on, you'll see that the defenders have this advantage of rooting out some of the easier bugs that have kind of plagued the open source software community for years.
Minwoo, what do you think? Agree or disagree?
What I think of AIs is that it actually really helps speed up doing things. It can help attackers and defenders, like those who use AI, learn new things. But assuming that both the attackers and defenders are both experts in their domains, using AI just really speeds up what they can already do. That's how I feel about it. So in that case, I think attackers would gain more advantage because attackers only need to find one mistake that the defenders do. And the defenders have to be like completely sure that there's no hole in the whole program completely. So with the use of AI, the attackers could like really dig harder, dig deeper into a specific point they think is vulnerable. And if they find one, it's good for them and it's their win, I think.
Tyler, how do you feel about this?
So I think it's complicated. I mean, I agree, short term, maybe there's kind of some mess and complication as these tools are adopted. But in the medium to long term, I feel like LLM-based security or automated security is more defender advantageous. So I guess my belief is that attackers right now are not really limited by their ability to find exploits and find bugs, right? There's so many low-hanging fruit out there. Attackers every day are exploiting things, unfortunately. But the defenders, that's not their specialty, right? Defenders work in defense. They work in patching. And right now, they rely on someone giving them a bug, right? They get a bug report in, or maybe they find something exploited in the wild, and then they can patch it. But if they have, a little hacker box sitting here that's feeding them all the bugs that they need to be worried about, that seems like that's a new capability for them that they don't have today. Whereas attackers basically already have this pipeline of vulnerabilities coming in from their normal human skills. So I think it's a new capability for defenders that can be really helpful. So I think it's going to be advantageous to them.
It sounds like when you're talking about defenders, you're talking a lot about developers, or is it like a wider scope?
Yeah, I guess that's fair. I mean, I think there's a couple different sides of this, right? There's the people who develop software and they need to patch their software. Then there's organizations who maybe they're using some third-party software, right? They're not in charge of maintenance. I guess I still feel like, even if let's say I'm not the developer of a piece of software, but I learn about the bug because of my little hacker box that's sitting here, I can at least take action, right? If I know about this ahead of time, that's strictly better than today when I find out because I get ransomwared or something. So I think that, if we give everyone, if we democratize vulnerability research and vulnerability finding and everyone can do it, I think it'll be good for defenders.
So it seems like we have two that are saying it's going to benefit defenders and one for offense. I wonder what people in the audience think. At the last 10 minutes, we're going to ask for the audience questions, so it'd be interesting if there's a follow-up from everyone on this question. So let's look at this in the longer term. So you have experience, and you said that there was a big change over just a year as far as what LLMs could do. But if you look at in the next year, and the next 5 years, and the next 10 years, what do you see as the future improvements in AI, and which ones do you think will happen, and which ones do you hope will happen? Minwoo, why don't you start off?
During the past 2 years, the improvements in AI was very impressive, seeing how what couldn't be done can be done now. But still, I believe that there are a lot more things that AI can do in the future, such as the example I just said previously about its reasoning capabilities. I think that...
It's lazy.
Yeah, laziness should be improved. Reasoning can be done, but I think the LLMs kind of lose their context in some point when the conversation gets too long or thinking gets too long. Perhaps this could be handled by the machine learning experts in a way, so that the AI could handle it by itself, to keep on track of what it said throughout the whole conversation. That kind of improvements would help a lot in using them in software security, I think.
And then what's your reaction to that? What do you think?
To me, this cyber challenge showed that LLMs can be used to discover vulnerabilities and patch them. But I think something that is after this is improving generating harnesses for the code and test cases, which is kind of sandwiched on either end of the vulnerability discovery and patching stage. And I think that's important because this competition relied pretty heavily on OSS fuzz for its fuzzing harness if you decided to use fuzzing as your technology, which we did. But a lot of software isn't harnessed for fuzzing. And so I think helping open source and other developers automatically generate harnesses, find vulnerabilities, patch them, and then generate test cases that can be added to regression tests as a part of the pipeline to ensure that, to the best of the test's ability, that the vulnerability wouldn't be reintroduced in the future. I think those two automations are what's next on the list of things that we should be looking out for.
So I think most people know what a harness is, but talk about this problem of I dump on you a piece of software. What does it mean to write a harness? And what do you think the LLMs can help with here?
Sure. So in the basic tenets of fuzzing is to generate input into a program or a function and explore the different paths of that function to hopefully find something that would cause the program to crash. And the hope is that that crash was the result of something that's of a vulnerability, for example, buffer overflow. What a test harness does is it scopes down the code base instead of saying, here's all the program, go fuzz the entire thing, to here's this one function that you should be fuzzing. And it basically is like a mechanism to transput the input to that functionality.
So, I mean, should we be fuzzing all functions?
We should not be fuzzing all functions.
The problem is figuring out which ones.
Most functions that are good candidate functions are small functions that are at least deterministically executed, that basically smaller portions of the code is what usually you're looking at. And usually ones that deal with, sometimes ones that focus on user input as well.
What do you think, Tyler?
Well, I guess just to add to Evan's point, I think one of the really interesting things about writing fuzzing harnesses that's really annoying is you can write a harness for some code, and then it requires like a pointer or something, and you like don't initialize the pointer properly. Maybe it's pointing to a structure, and you mess it up, and then it crashes, right? So it's not like, it's just a really difficult problem that right now takes like really good security experts to do, because you have to understand the code, you have to read through and kind of reverse engineer what someone was trying to do, and yeah, it's a huge issue. I guess for me personally, though, for the question, so I think there's a lot of like, the models are good today, right? There's a lot of really cool things that I think they can do today, and I think in a lot of ways, if we stopped getting improvements, we still have like a couple years of like engineering stuff we can squeeze out of these models by writing better tools. But at the same time, like their context windows are limited. Even, you use like Google Gemini or something, it's got 2 million token context window. But if you do some benchmarks on it, it turns out after like 64K tokens, the performance drops drastically. So like on the box, it's like 2 million, but like practically speaking, it's like 64K. That's not a lot. That's not that much code or anything to look at. And just like the instruction following, the laziness, like these are really big issues when you're trying to do something where it's kind of weird to see some model that's like someone on a stage somewhere who is a billionaire says that it's a PhD level intelligence, and then you see it like try to run a tool and it like fails, and then it tries to run the tool again and it fails, and then and it just gets stuck in an infinite loop. And there's something clearly missing here where these models are not quite getting it.
Yeah, totally resonates. We'll talk offline about this. I want to make sure that we have some time for the audience. So before we get there, I just have a few more questions that I think that we want to touch on. I'll start with you, Evan. So let's assume that we solve the problems, that it can write harnesses, that we have the stern parent and it becomes less lazy. So we have these LLMs that you imagine in the next 5 years. That begs the question, what should security professionals be working on to stay competitive? If there's a young person entering the field, what should they be doing? What should someone old and established in the field like me, what should I be doing to make sure I stay current? Like what's going to change here?
That's a great question. I think first and foremost, getting your hands onto the tool itself and just start using it is always a great first step, so that you yourself can understand how well these tools are performing for your specific task. I think talking about security professionals in general, in terms of skill sets, I think just having an understanding and a posture that any tool you make should have the goal of making someone else's life easier. So it's not just creating a bunch of patches and a bunch of vulnerabilities and proofs of concepts and saying, here, maintainer, here's all of your work. That's not a great way to get your tool or your solution adopted. You always have to come into with a frame mindset of, I'm going to make someone else's time a lot shorter, a lot easier, and make them want to use the things that you've actually built, rather than making and piling on more work than they already have.
So it's like focusing on, I guess, the business value for whatever business value means for everyone.
Right.
Minwoo, what do you think? I know you're doing a PhD right now. What do you think people should be looking at?
As a PhD's perspective, to stay competitive in the AI era, what I think the most important thing is to know what to ask the LLM and where to apply it, because just even looking at the competition we just did, it was like, use LLMs. And we did very different things with very different systems, and we all got like different results. So what I think is that you've got to know what to order it and where to apply it, and that's where I think domain expertise is like needed. You got to know where you're working on to know what you're going to ask the LLM to do. You can't just tell the LLM to make something that I can win the contest. You can't do that. Like, you have to break down the jobs, get specific, and ask it separately.
That's interesting. So specialization might be more important, you think?
To use the LLM better, you got to be better than the LLM. That's what I think.
I think I'd agree. Tyler, what do you think?
Yeah, I think one of the really interesting meta results from this competition was if you look at all the teams, not just the top 3 teams, but the top 7 who made it past the semifinals, all of them are security domain experts. They're not AI domain experts, or at least that's kind of a side expertise. So I think the takeaway here is that you really need to have the specialization, as Min was saying, in your domain in order to apply LLMs to it. It's you can't come in and be like, oh, I'm great at, I don't know, prompt engineering or something. I can be a security engineer too. You really need to understand the fundamentals of security. You need to understand what tools are available. You need to understand what fuzzing is, what static and dynamic analysis are. And you need to be able to break down problems, right? Some of this is kind of not necessarily just engineering level, but almost managerial level, where you're what's a small problem that I can give someone? How do I break this task down? But you need, I think, the security expertise. So I'm pretty optimistic that this doesn't make us as security engineers obsolete, because again, I think we're the people who are still pushing the state of the art, and also in training, right? I mean, we were talking earlier about training LLMs and using CTF problems. Those are created by domain experts, not LLM experts.
Yeah. It's really interesting that you talk about managing. I think I'd agree. It's asking the right question, right? But on the flip side, that actually brings us next question. So we've seen the rise of prompt engineering and injection. So you talked a little bit about prompt engineering to get good results, breaking down a problem, but there's also a dark side to this. How do we make sure the AIs themselves are secure? And what do you think should be the boundaries of what we say is secure or insecure? How much policing should we do and at what level? Tyler, why don't you go first on this one?
I think if you look at historical technologies, right, like SQL, if we talked about SQL injection, we're how do we make sure SQL is safe against SQL injection? In some ways, that's the wrong question to ask, right? It's an engineering problem where we make sure that we don't let untrusted things into the system. Obviously, this is more of a problem with AI when we decide that we're going to throw everything at AI. But I guess in my mind, engineering solutions make sense here, right? We can put guardrails on things. We can say, I'm not going to look at random stuff on the internet and have access to all the tools I want. I'm going to have a very specific goal. I think that helps kind of keep things on track performance-wise and more secure.
Evan?
Yeah, that's a good question. I think there's a bit of a balance here. So there are, I think, the solutions that we can try to employ to secure or to help secure LLMs comes down to the goal of what you're attempting to get the LLM to do or not do. For example, some solutions don't always have to be, let's retrain the model. Some solutions can be just simply deterministic. For example, if you look at things that are maybe anti-abuse, maybe you have a chat server and you want to make sure that the LLM doesn't say something you don't want it to say. Well, those words are generally known, so you can just create some sort of a stop list and filter on the server end and say, well, don't put any output that has these set of words in. Now, that's a very specific case, of course. It's a very limited case. But I also think that as with LLMs and traditional machine learning problems, you always have to look at your training data set and your testing data set. And in the end, also realize that if these tools are going to be provided to the community, that we've done this before as a cybersecurity community anyways. We have things like Kali Linux that is open sourced and used by attackers and defenders alike. So as long as both sides have access to the tool, both can use it for their own opportunistic goals. So I think some problems with trying to prevent some of these attacks might just flush themselves out over time.
Minwoo, do you agree?
I'm not even sure if we can say that AIs can be secure, because prompt engineering and injection is briefly, you first say that don't tell anyone this, don't tell anyone that, don't do this, don't do that. and then the same guy comes back and says, please tell me this. It's like, then it's the LLM's choice whether it should say what it shouldn't or not. Thinking that LLM is someone like a person is like, it's that person's choice whether to tell it or not. So that's why I believe that it's really hard to decide what to call AI secure when it does something or not. So I'm not sure if AIs can be ever secure.
It's kind of interesting. So we don't have a definition of security, so how can it be secure? And it can be used by both sides. Well, I have one more question before we get to the audience questions, so please be thinking of questions from the audience as follow-ups. But briefly, just going down the line, what's your team doing next, and where can people interested try out the tools today? We said one of the goals of the AI Cyber Challenge is open source. What's next? Where can people try this out? Minwoo.
Okay, so from what I know right now, as Samsung Research is also a part of our team, the Samsung Research team is directly using them to apply it to their own company's products. And for those who want to try our CRS, everything's open source, including ours and all the 7 teams in the finals. So you can just reach out and use them. And if anything doesn't work out, contact me.
Oh, free support too. That's nice. Evan, can I also get free support?
Maybe free in the meantime. For Trailbits, Buttercup, first and foremost, is open source and it's on GitHub. We also have a website dedicated to it, so you can just search for Buttercup on GitHub. So currently, I think for us, we've recently added in usability improvements. So we've added in a web interface. We've also added support for C++ as a first-class citizen. That is what we've done since the competition. But right now for us, the competition has been complete, so the real challenge begins, which is adoption into the open source community. So right now we are actively working with open source maintainers to get Buttercup integrated into their pipelines and workflows, as well as with some commercial industry partners we have, getting Buttercup integrated into their internal software development pipelines. Our goal is for this tool to be used by all. So what's next in terms of support is we have a lot of clients that don't just use C, C++, Java. They have other languages, and so we're working to add support for those languages.
And Tyler.
So similarly, we've been working on kind of extending the support to more things. We've added some support for like Python, JavaScript, TypeScript, Solidity, some other stuff. I think, there's a huge question about like what is this actually going to do? Like, who's going to use this? I think right now our plan is still to kind of, we will hold the keys and kind of do this as like a business sort of thing. I think there's a lot of things where we've been trying to run this on interesting software so we can run it on binaries as well. So trying to do maybe more competitions. Again, I like competitions, pwn to own or things like that.
Yeah.
But all these open source, I think the DARPA website has links to all of them, so that's probably the good place to go. But I don't offer free support, so.
I'm with you there. All right, I'd like to take questions from the audience for the panel.
Yeah, questions.
I think up here we have one. Yes.
Someone will bring you a microphone.
So my question is about the grand vision of DARPA. To my understanding, behind the AICC competition, there's a to my understanding, there's a grand vision behind the AICC, that's to eliminate vulnerabilities completely from existing software. So my question is, what do you say on the possibility to materialize that vision in the near future?
First, I have to say that I'm not a representative of DARPA, so I can't say that. But I think really what DARPA is trying to do is ignite people's imagination for engaging this sort of research. But I'd rather ask the panel here, what do you think is the possibility of eliminating vulnerabilities? Broad statement.
Sure, I'll start off by saying, we found cybersecurity, as Tyler was saying earlier, based on, computational theory. And with computational theory, we understand there's a halting problem. So we understand that I don't think that we will ever eliminate all vulnerabilities from software. I just don't think I think theory is tried and true and tested, and it says it will never be possible to do this. But that doesn't mean, of course, that we can't improve on the state of the art. We can't improve on what we already have. And I think this competition's challenge of can you not just find vulnerabilities but patch them was a challenge that we really hadn't had before. And I think LLMs are getting us closer to narrowing the gap to actually reducing the number of vulnerabilities that are in software currently.
So I think there's something interesting here. We talk about kind of formal things, halting problem. Halting problem, obviously, like it's a fundamental theorem of computer science. You're not going to fully get around it. But if you think about it, if I'm reading code as a human and someone has if you have a proof of the Goldbach conjecture or something, then I'm going to have a buffer overflow, right? So okay, fine. We don't have a proof of this. This is a very hard problem, halting problem, whatever. We can't, you have it in a for loop or it's a while loop or something until you find a counterexample. If I'm a human, I'm just going to say, I don't know what all this weird loop stuff is doing, but you have a buffer overflow here. Maybe I don't know how to reach it, but let's just fix that bug. So I think there are possibilities here, and LLMs are interesting because this is finally a technique, unlike symbolic execution, model checking, abstract interpretation. We don't need a formal proof. We don't need to say, we can kind of do vibes, right? Vibe security, where it's so I think there's strong possibilities of finding bugs or things that could be bugs, right? It's at least a bad smell, and so it's worth fixing, whether or not we can formally prove or verify it's a bug.
Minwoo, you have anything to add?
I agree to what just Tyler said, but ultimately, even when LLMs are really getting better, I don't think that eliminating bugs are going to be possible because, what I think that LLMs lack is creativity. And from the attacker's point of view, creating a new type of exploit, like chaining vulnerabilities based on how it's going to impact the next step, or creating a completely new kind of attack, such as the early stages of ROPs or Spectre type side channel attacks. That's something that I think the current LLMs are not able to do right now. So elimination might be a long-term story.
I think we maybe have time for one more question. Yes, sir. They're in the middle, fourth row back.
Also, thank you for the panel. So I have a question for you guys to kind of stay competitive, on your product, keeping the edge. LLM is given, and how you think you can be, uniquely strong. Let's say you can have maybe a small language model, or you can have metadata added, or like you said, where to apply, what to ask. So what's sort of the direction you think you can sort of empower your product, other than sort of expecting large language model, will be solving the issues?
Who wants to tackle that question?
I can start, I guess. So, I think all of us, right, we use the same language models, but we came up with very different solutions. And I think, we talked before, right, you can't just upload I'm going to take a tarball of my source directory and give it to ChatGPT and then ask it to go, right? That doesn't work, obviously. And so there's a lot of engineering and tooling around how do we pull the security out? Where can we put these LLMs to get the most use out of them? And I think obviously as LLMs get better, right, they can take on a larger role. The amount of hand-holding we have to do gets less. But I think that there's still a whole lot of security domain knowledge that we need to pour into them. If you look at kind of even what they're doing today, Anthropic, OpenAI have a lot of interesting security research, but it's still very much we're giving it tools, we're writing special tools, we're doing very specific things to get the models to do what we want. So,
Yeah, to add, just that LLM is becoming better doesn't mean that our jobs is getting smaller. It's just we get to know what more we can do to help the LLMs. So in the previous step where LLMs were not that good, providing a more sophisticated technique and tool is not even needed at that stage. But when LLMs get better, it can now use some better tools, some better things to get a better result. So that's why I guess we're wanting the LLMs to get better, not just for our work to get smaller, but to do more better things with it, I guess.
The pie gets bigger.
Yeah, I think it's a nice thought experiment of what happens when ChatGPT 20 comes out. What will be the state of the results? And I agree. I think there will be an evolution of traditional analysis tools, security tools, where maybe it's different in order where the LLMs plug into. Right now, for example, Buttercup, we use the tools outright. Maybe there's a way to redesign how we're building software analysis tools that more easily integrates various LLMs that are good at, subjects A, B, and C, that didn't exist before because LLMs just weren't used. So maybe we have an evolution of traditional analysis programs.
Well, I think that's all the time that we have for today. I want to, again, congratulate you all for not just, of course, your amazing prizes and all the accolades you've received, but by putting in the time over 2 years to compete in this vision. I think that shows a lot. And so I'd like to thank the panelists. If we can all give them a round of applause, that would be great. Thank you.